Okay, so question number 1834, single threaded CPU. Today's Leetcode's daily challenge. So we are given with an array of arrays, a 2D matrix basically. Uh, each row contains each process. So uh, we are given that in tasks array, each task that is at index I has its enqueue time, means at which time it arrives, and its processing time. So what we are told to do is we need to uh, create a order, and we have to tell that in which order the CPU will process these items. So we are told to process all of those items, and we need to return the order at which order of processing. So we are given with this following rules. Let me read it one by one. First is that if CPU is idle and there are no available tasks to process, the CPU will remain idle. And the second one is if the CPU is idle and there are available tasks, the CPU will choose the task which has shortest processing time. If two tasks have same processing time, then it will select the one which has smallest index. Third rule is once a task is started, the CPU will complete that task. It can't preempt to any other task. Fourth rule is the CPU can finish a task, then start a new task instantly. So there is no need to cool down the CPU. So now let us try with this first test case. So what test case is saying is that we have the array 1 2 2 4 3 2 and 4 1 as process. So uh, yeah, let's start. Let us just declare a output array. Initially it will be empty, and let us say our CPU's time is this 0 initially. So we will scan through whole array and see if is there any process available at time t is equals to 0. So what we can see is there is no available process at this time. So what we can do is yeah, one more thing is that it is not by default from the question given that this particular array will be sorted. It's just a coincidence that this test case shows that it's sorted. So we'll sort this array itself first. First task will be that. So we will directly jump to the first element's arrival time, because all other elements after that will arrive after that or at that time. So we can safely say that we can skip the time. We can safely say that we can skip the time to the first process arrival time or the process arrival time. So we'll change the time to 1 at now we will scan again through the array and find all the processes which start at time t is equals to 1. So we can see that we have this first process itself. So we'll add it, so we'll process it, and it will take 2 units of time. So now our time will be 1 plus 2 3, and this process is done. So we can mark it with -1 or something like that. Also we can keep a counter. So this process is done, we will move forward. Now we will check from here only. Now at t is equals to 3, how many processes are there? So we can see that we have these two processes. So out of these two processes, the process which we will select should follow this rule, the second rule here. So according to that rule, we should select the process which has shortest processing time. So it is 2. So we select this process. We again mark it -1, and it had a processing time 2. So we process it. Now time variable is 3. And one more thing is we need to keep track of the element, like in which order we are taking it. So 0 2. Yeah, now t is equals to 5. How many processes we have at that time? This process we already have, and this process we also will have. So out of 2 we will again select the smallest, the shortest processing time process. So we'll select this. Time will be 6 now. We process third index process, so uh, we track it in output array. Now at t is equals to 6 we have one process, so we will process it, marking it as -1, pushing it into our output, and time will be changed to 7 now. Now what we can see is the size of our output array is equal to size of input array, that is task. So we can safely terminate uh, this program. So now let's see code for this program, code for this problem. So this is the brute force solution which we just discussed right now. So here we can see that first of all we will declare a variable, time variable, output array, and we will run a loop until the output size and the task which we were given with has the same size. So all processes are done, in short. So for each and every single iteration we need to decide that which process is the one which we will execute. So we need to decide it by scanning through the whole array. So the best candidate we will store it here. So we will iterate to the array and we will check that the candidate which we are selecting should have the least processing time among all of those which are available at that time. So here we can see we are doing that only. And one more thing is, once we select any process, we should mark it with -1. We will do it later in this code only, but this is the thing to be remember. We have needed to remember, otherwise we will we will do one process multiple times. After that, if suppose that we are at time where there is no process, so what should we do in that case? What we can do is we can directly jump to the time at which the process is the earliest process is available. So we will also keep track for that, and just in case we don't have any candidate for current time, we will jump to the next possible time at which the process is guaranteed to be there. We can also increase it by say 1 unit every single time, but no need to increase that much time complexity. At last we will push it in output array, and then we will mark that particular process -1, which means that we won't process it again and it's already processed. We will increase the time. After that we will return the output array. Now the issue with this approach is that we are scanning through this array again and again and again, so it can increase the time complexity. So if we see, we have one loop, inside of that we have another loop, and each so we are traveling say n iterations in this loop, and this bigger loop also n iterations. So we are say doing n cross n, that is n square n square complexity. We go of n square plus some polynomial, say constants. Of this code, this code will run n square time. So what we can do is we can optimize it. Now how can we optimize it is a question. So we need to see the we need to find some observations in this. From the rule itself it is clear, however let's just go back. Yeah, so in rule we are given that specific metric how to choose any process from bunch of processes available at that time. So we can consider this factor this matrix as a priority. And as we have this matrix as priority, this is a hint to use the priority queue or a heap. So let's implement the that heap based solution. So here you can see we have the heap based solution. So in this solution we did some other tweaks as well. I will just show you it in a moment. So first of all, we will actually create a comparator class. What this comparator class is doing is basically it is giving a boolean false or true. It will help to sort the elements inside a heap. So first priority will be obviously to see the processing time, and second one will be the ID. If the processing time is same, then we will see the ID. We define this macro so that we don't need to write this array of size 3 again and again. Now let's just move to the important part. Yeah, so we declared a time variable again this time as well. We declared array. Now this time we declared a priority queue, and how the elements will be queued in it is we defined in this comparator class. So we will store element as three. So each element will have 3 integers in it. What first integer will be is it will be processing time. So not processing time, sorry. First one will be arrival time, second will be processing time, third will be its index. Now it is in question not mandatory that the input will be always sorted, so we need to sort it, but we also need to store its original index with that element itself. That's why we can't use the provided array itself. So we make a new array. After that we push back all elements into the new array with its index, as you can see here, as third element. After that we can safely sort the array. Now we need to sort it by first column. So what we can do is we can use custom comparator. Here I used a lambda function. So here I compared their arrival times to sort the tasks array. Now you can skip this part, it was just for debugging. Yeah, so again the same loop till the output is not equals to the task. We will basically run the iteration. So what we will run in the iteration is, if the CPU at the current time does not have any process, so our queue is empty and our time is less than the earliest available process arrival time, so we can directly jump to that time. After that, in the same iteration, what we can do is we can select every single process from that array which is available at that time, which means that that process we already didn't executed, and that process is available to us at current time or time before it current time. So we just use this condition and push each and every available elements. Also, to start from the next element only, we keep track of the index. This will help us. We do not need to actually change any process to -1 or pop off, so we can maintain an index separately for that. Now to execute any process, what we will do is we will pop off the top element from priority queue. We will see what is its arrival time is, however, it won't be needed, as we already at the t the current time, how much time it will take to process, and its index. So we will execute it. So at next time, the CPU will be at this time, so current time plus how much time it will take to process. After that, we will push it to our output, its index to our output, and we can safely pop it off. We will run this iteration until we process all our processes, and when we will be done with the process, will be with execution of all processes, our output array size will be equal to input array size. So this is the most optimal solution, and what we can say is its complexity will be n log n, where n is the size of input. And for space complexity, you can see that we have declared these variables. This was for output, so you don't need to count it. This it can take big O of n. I declared this, which also can take big O of n. We used sorting, so yeah, it will also take some time complexity, just in case if it is not in place merge sort, or let's just consider it is a in place merge sort. So these are two spaces which we declared. So yeah, code's link will be in description. Thank you for watching.